What you can remember is from the quadratic formula, and we're dealing with the discriminant, and we learned this in the previous section, is the discriminant is the piece that is underneath the square root, the b squared minus 4ac. And what we've talked about so far is that we have several cases that we can look at from this situation. So if we look at this first one with a perfect square, I'm actually not a fan of how they write this little dash in here. Maybe what they should have done is put an arrow. I don't really know. But what they're trying to get you to realize is just a reminder that A equals 1, B equals 3, and C equals negative 10. That if you were to plug this in, 3 squared minus 4 times 1 times negative 10, just a reminder that you have to square before you multiply, but 4 times negative 10 is positive 40. Well, negative times negative is a positive, so we're looking at 49. So if we were to go through the process and we actually did all of the answer, I know that the square root of 49 is 7 all over 2a. So as a reminder, this is the same thing as negative 3 plus 7 divided by 2. All right, so that's positive 4 divided by 2, which is 2. But then this one would be negative 3 minus 7 divided by 2, so that's negative 10 divided by 2, which is negative 5. So these are the two roots, but what we care about is that there are two rational roots. These are rational numbers. And just if you look at the answer key, they also take it one step further and they talk about them being unequal, which is kind of important. But I'm going to distinguish between this one and a later situation by just saying that there's one rational root. But either way you go about doing it, let's look at the next one. And again, I'm not a big fan that we have this dash right here. I almost wish it said an arrow. But if you consider that it's negative 6 when you square it, minus 4 times a is 1 and c is 7. So we're looking at 36 minus 28, which I know is 8. Well, if you go through that process of negative b plus or minus the square root of 8 all over 2a, just as a reminder, we might rewrite this as 6 plus or minus 2 root 2 all over 2, where you might see me write it as 6 divided by 2 is 3, and 2 divided by 2 is 1, root 2. So it still has two roots, except now we have irrational, because I don't know the square root of 2. It's an irrational number. So that's all I'm going to say about this. But the directions also talk about it being unequal. They're not the same number. 3 plus root 2 is different than 3 minus root 2. But the next section, again, I'm just going to change colors just to distinguish. But if you go through the work and you do negative b squared, okay, so it's just b squared, minus 4 times 1 times 25, a and c. This time you get 100 minus 100, which equals 0. So this time if you were to actually find the roots, negative b plus or minus the square root of 0 all over 2a, well, that's kind of silly because adding 0 is the same thing as subtracting 0. So to me, it makes more sense just to say that there's one rational root. But technically speaking, I get why the answer key says that there's two roots. Because if it's a quadratic like this, it's supposed to have two roots. And we'll talk more about that as we get deeper into the class and into pre-calculus, where it makes sense to say that they have two equal rational roots. That technically speaking, it is 10 plus 0 divided by 2 is 5, and 10 minus 0 divided by 2 is still equal to 5. So I get the reason, but to me it's safe just to say there's one rational root. There's one time it hits the x-axis. And then our fourth situation is this one, where if you go through the process of, I know it's -8, once you square it, it's going to be positive 64. 4 times 1 times 20. So we have 64 minus 80 is -16. So with a negative square root, 8 plus or minus the square root of -16 all over 2a, just a reminder that the square root of a negative makes it an I, imaginary, and square root of 16 is 4. And I would want you to divide each piece. 8 divided by 2 is 4, and 4 divided by 2 is 2. So here's a situation where we have two imaginary roots. And what does that mean? It does not cross the x-axis. Or it doesn't even touch the x-axis. So as we move into the next exercise, we can basically break it down to all of those situations. So all we need is the discriminant. Just a reminder, it's b squared minus 4ac. And compare it to 0. Yeah, it's either going to be positive, negative, or 0. And then we also have perfect square numbers. So if I go through the work, 7 squared minus 4ac. And you're welcome to use a calculator, but this is just 49 plus, what's that? 8 times 4 is 32. So that's going to equal 81. Okay, well, I know the square root of 81 is exactly 9. So first of all, it's a positive number. Maybe I should jot that down. So I will get two real roots. It's not imaginary, but more specifically, they will be rational roots because I know the square root of 9. So as I go through the next one, and you can actually just drop the negative when you're doing the discriminant, because whether you square a negative or a positive, you'll get positive 64 minus 100. And all I care about is that I get a negative on this one. And the fact that it's a negative tells me that I have two imaginary roots. So it does not cross the x-axis. And just a little bit more, because to me, if I have two, then they must be unequal roots. I don't know if you'll come across that as we progress through this. But anyway, if we do b squared minus 4ac, what you'll see is you'll get 16 minus 16 is equal to 0. And because it equals 0, think about the plus or minus, the square root is 0. So there's one real rational root. But again, the answer key might, because it is the equal, it's supposed to have, it's a double root. And we'll actually talk about that in the next exercise, exercise 3. If I go back through, just repeat the process, and 6 squared minus 4ac, then we have 36, let's see, minus 60, and all I care about is that that number is less than 0, because it is, that we're going to have two unequal imaginary roots. So it does not cross the x-axis. Same thing with the next one. You might just drop the negative. 4 squared is 16 minus 4 times negative 7. Maybe even use a calculator on this. 16, whoops, minus 4 times negative 7. Give me 128. Now it is a positive number, but I don't know the square root of 128. So the fact that we don't know the square root of 128 is going to tell me that this is an irrational root. Two unequal, irrational roots. Just so you know, the only time you get equal rational roots is when it's one rational. It's a double root. Let's see if that happens on the next one. Again, it's going to be positive 49 minus 4 times 3 times 2. So if you don't trust yourself with a calculator, feel free to use it. 7 squared minus 4 times, I already forgot, 3 times 2 to get you 25. Okay, well, I know the square root of 25. So yeah, it's greater than 0, but since the square root of 25 is 5, then we have two unequal, but they are rational roots. So what do I mean by having rational roots? And you can play around with the graphing calculator if you have access to one. But if you were to go through the discriminant on this and do b squared minus 4ac, and we end up with 16 minus 16, which is 0, then what it's going to do, well, let's factor this real quick. If I asked you to factor that, it would be x minus 2, x minus 2. And if I asked you for the x-intercepts, you would set it equal to 0, and so you could see that x equals 2 twice, or you could actually do the quadratic formula. So it would be about right here with a y-intercept of 4, and then it's reflected on this side. And so this is what we mean by being a double root, is it bounces off the x-axis. And the math term that we use is it's actually tangent to the x-axis. But kind of in layman's terms, it's going to bounce off the x-axis. And that's what it means to be a double root. And sometimes we actually use the phrase that has a multiplicity of 2. So put this in your back pocket. We might come back to it later this year, or bring it back in pre-calculus. And here's another situation where they want you to find the two unequal but rational roots, and you can go through and you can just find each one, and do b squared. Well, 2 squared is 4 minus 4ac. All right. Well, if you do that properly, you'll get 4 plus 4 is 8. Well, I don't know the square root of 8, so it's not rational. If I go through the next one, we have 4 minus 4 times a times negative 15. All right, now we're, 4 plus 60 is 64. I'm thinking that's it. And you can confirm the other ones don't work. 64 minus 4 times 1 times 16. Oh, we're back at 0, so there's one equal root. And then this one would be 9 minus 4 times 1 times 5. 9 minus 20 is a negative number, so that's imaginary. And that's actually what we're going to use on this last one, is think about what has to happen to not cross the x-axis. Well, if it's not crossing the x-axis, the discriminant, BAC, must be a negative number. So all we know in this problem is that B is 4. We don't know A, but we know C is 2, that if we multiply all that together, it needs to be a negative number. So what we have is 16 minus 8A, because multiplication is commutative. And if you subtract 16 over, just remember that when you divide by a negative, you have to flip the inequality. So A must be greater than negative 16 divided by negative 8 is positive 2. Flip the inequality. And you should be ready for the homework now.